Alright, we'll go through the solutions to the test revision. The first one, y equals 6 plus 8, that's in the format y equals mx plus c. That's slope-intercept form. That's the slope, that's the intercept. And to fill out this row here, slope's very easy. That's 6 because m is 6, so you write that there. The c is 8, y-intercept, you write that there. It doesn't have any asymptote because if there is no place where you could have 0 on the denominator, because there is no denominator, so there is no asymptote. Now the x-intercept is when y equals 0. So if you put y equals 0 into that equation, you'll get 0 equals 6x plus 8. And if you take 8 over the other side, you get minus 8 equals 6x. And now opposite of times 6 is divide 6, so x equals minus 8 on 6. And that's what we're getting here as the x-intercept. The next one is y equals 8 take x. We want it again in y equals mx plus c format. So to rearrange that, it'd be best to write the x first. It's really minus x plus 8. Now if you look at the m, it's really minus 1. It's minus 1x, so that's why the slope is minus 1. If you look at the c, it is 8. That's why in the y-intercept we put 8. There is no asymptote because it isn't over 0 at any point. The x-intercept is when y equals 0, so we put 0 there, and then to solve for x, it's minus x, we'll take it out of the side to make plus x, and so x equals 8, that's the x-intercept. The next one you could rearrange into what y equals mx plus c, or you could keep it in general form. In general form, it is ax take by equals ax1 take by1. Slope being a on b, so it's going to be 3 on 1 because we have 3x take 1y equals, and all of this is a number 6. Now the slope is a on b, so it's 3 on 1, and that's why the slope here is 3. The asymptote, there is no denial, although we can rearrange this. I'll take y to the other side, and we get and 6 on the other side, so 3x take 6 equals positive y. Notice using this other format, the slope is 3, which is agreeing with what we just did. This is actually giving us the y-intercept as minus 6, which is over here. And there is no asymptote because once again it's never undefined. You're not dividing it by 0, so there's none. The x-intercept, we put y as 0, so if you put 0 there, you have 3x take 6 equals 0. And now take 6 over the other side. Opposite of minus 6 is plus 6. Opposite times 3 is divide 3. So 6 divide 3, which is 2, and that's what we write for the x-intercept. The next one here is a fraction. Once again, we need to get in y equals mx plus c format. Now, fractions mean that when you divide by 3, x plus 2 on 3, that's the same as the first term divided by 3 and the second term divided by 3. X on 3 is the same as a third times x, because that's really like x on 1. 1 times x is x, 3 times 1 is 3. And now there's your m, there's your c. So your slope is a third, that's there. Your y-intercept c is 2/3, that's that one there. There is no asymptote because it's never 0 on the bottom, it's always 3 on the bottom, so it's always defined. The x-intercept is when y equals 0, so if we put 0 into here, you have 0 equals x plus 2 on 3. If you times by 3 over the other side, you'll just have 0 equals x plus 2. If you take 2 over the other side, you've got x equals minus 2. So our x-intercept is minus 2. And the last one is a rational function, 1 on x take 2. Now to get the slope of sorry, hang on, we'll just check what I've just, this one, yeah, that one there's the slope. To get the slope, this one here is, it's got a slope which is constantly changing, because this graph, if we were to sketch it, it would be the asymptote is occurring over at 2. There's 1, there's 2. There's your asymptote, because when x is 2, it's going to make the bottom 0, so this will be undefined, and that's why the asymptote here is the x equals 2 line. And the graph of this would be a curved thing like that. You can see the slope is always changing. When you talk about this fixed slope, if you've got a straight line like that, then the slope is fixed. It's not that it doesn't have a slope, it's just that the slope's always changing. So we can't really answer that question in year 11. We leave that for year 12. Now, the x-intercept and y-intercept. So to get the x-intercept, we need to put y equals 0. To get the y-intercept, we need to put x equals 0. So for the x-intercept, if we put 0 equals 1 over x take 2, and then you multiply over 0 by x take 2, because at the moment it's being divided by x take 2, you'll have this next line, 0 times x take 2 equals 1. Now anything times 0 is 0, and you get 0 equals 1, which is silly. So what that means that there can't be any x-intercept, which is why we've got none there. Now the y-intercept when x is 0, so same thing, 1 over, but instead of x you're going to put 0, so you end up with 1 over minus 2, which is minus a half, and that's that one there. Okay, now we go on to question 2. Question 2 is a plotting question, and we've got the time of revision and the exam scores. Now if you plot them, you get this sort of a graph come up. Notice you should actually do the scaling so that you're using most of the grid paper there. And then once you've plotted them, you then try and do a line of best fit, where you go through the bulk of most of the points with minimal amount of distance for the points sitting outside the line. Now you can do all this manually, and you can check it on the graphics calculator. We have to find the equation linking these two variables together. I've put time on the x-axis because time is the independent variable. It also, there's a hint here, it said plot a graph of scores versus revision. You always say y versus x. Now to work out the equation, we need a slope and a point, so that we can use y equals mx plus c. And to work out the slope, we need to get 2 points that actually are lying on the line. Now 2 points that lie on the line would be this one here, which actually is 8.25, and that's the point written there. And the other point we could choose is this one. See, those two seem to be good points that lie on the line. That one there, could have chosen that, but these aren't lying on the line, so we wouldn't use them. So to work out the slope between these 2 points, we're going to use y2 take y1 on x2 take x1, and that's what's written here. So it's 49 take 25 or 29 take 28, and we get 1.1. To get the y-intercept, you can see over here it's cutting the y-axis at around about 15, so we can say the y-intercept is 15. And so therefore y equals mx plus c is that equation there. Now we can substitute y and x for the actual variables. Y actually is the score, the exam score. X is the time spent revising. So this is now an equation that will convert your time for revision into a predicted score grade for the test. And you could do that on the graphics calculator as well. I'll do that now. You need to enter the statistics in by pressing the stat key and edit, and you can see I've entered the data already. I've put the X values, which is the revision time, in list 1, and the score values, the Y values, in list 2. To plot them, you need to go second stat plot. You go into plot 1, switch it, lock it on, you select the dotted graph, and by default it recognises list 1 as X, list 2 as Y. And now we can just do zoom stat, so zoom 9, and there are the points plotted. Now we want to get the line of best fit, which is called the regression equation. We need to go stat, go across to calc, go down to lin reg, which is number 4, and we go down to store regression equation. We want to actually store it into the y function. It's a variable, so we press vars, y vars, function y1, so it'll paste the answer into y1. Go down to calculate and press enter. It works out our equation for us. If we press the y equals, it's put the equation into the y1, and then when we press graph, there's our line of best fit through the points. Now the extra bit we can get from the calculator is the R² value, which is the strength of this correlation. If all those points lined in a straight line, we'd have 100% correlation. Because these points are off, then the correlation won't be all as strong as 100%. We'll see now. You have to go to mode and to switch the diagnostics on. So if you go down to stat diagnostics, at the moment it is locked on off. We have to put that on, lock it on with enter, and then you go back and do that same thing, stat, calc, go down to lin reg, and this time we'll just jump straight down the calculator. Don't need to see the graphic to do that. So go calculate, and you can see the R² is 58. Now that's 58%, read that as 58% correlation, strength of the correlation. So if we come back to the test here, we can see that is similar to the equation we got, is similar to what we got manually. Go down to part 3, and it says use your graph to determine the time required for 95% score. So you write the equation down there, you put 95% for the score. Notice the score actually is in percentage, but we don't need to put 0.95, it's actually raw scores out of 100. So put 95 for score, we leave t as an unknown and solve for t. If you take 15 over the other side, opposite plus 15 is minus 15, you get 80. Opposite times 1.1 is divide 1.1, and so we end up with, I'll just get rid of that. And so we end up with t equals 81. We get 73 hours. So you need to put 73 hours revision in 3 weeks to get 95% for the test. That's predicted based on everyone else's values plotted as a relationship on a graph. Okay, now we go on to question 3. Question 3 is 2 points you want to plot, so that's easy. You go back to up 1, next one's 5, 4, across 5, up 4. And then the following questions are asking you to use those points to find out other things, like this one's the slope. It's saying now pretend that these points represent a side-on view of a flying fox. So you'd have a line like this. So obviously the person starts here and they go down the flying fox and they end up there. Now to work out the slope, obviously you're going to do y2 take y1 on x2 take x1. So that's going to be that take that, 4 take 1 on 5 take minus 2, which is 3 on 7. You have to write down the equation, so it's y equals mx plus c. We've already worked out it's 3 on 7 the slope, so it's 3/7 x plus c. To work out the unknown c, notice we don't know where it cuts the y-axis. We could try and guess. It looks like about 0,2, but it's best if we do it algebraically. And to do that, you sub in any point. So sub in minus 2, 1. 1 goes where y is, minus 2 goes where x is. Work out that fraction, add 6 on 7, and so you get 13 on 7 as the c value. So it's almost 2, but not exactly equal to 2. So we can say our equation is 3/7 x plus 13 on 7. Now that's the slope-intercept form, y equals mx plus c. The question asks for a general form as well. So we need it in ax take by. First of all, we need to get rid of the denominator. We're going to times everything by 7, times that by 7, that by 7, that by 7. So it'll be 7y. If you times 3/7 by 7, 7 cancels, so that's 3x, and this is 13. And now we can rearrange that so it's in ax take by format, and so there's your general form. Now part D, how high would someone be on the Flying Fox after travelling 2 meters horizontally? So what that's saying is, if you're starting here and you go 2 meters horizontally, that means you're going that way. How high are you going to be on this Flying Fox? So they're asking, what is this height here? You've travelled 2 meters that way, and so how far up, or in this case, how far down have you gone, or how high are you from the ground? But notice they haven't actually specified the ground, so it'd be best to say how high you are from the end point. So 2 meters across, if you go 2 meters across, you're at this point here. How far up from the finish are you on the Flying Fox? That's really what the question's asking. So come back down to D. Here we are. So how high would someone be on the Flying Fox after travelling 2 meters horizontally? So if you're 2 meters left of 5, 4, that means instead of being x coordinate 5, you have an x coordinate of 3. So you've got to sub x equals 3 into the equation. If you put 3 in, you will get, after you work all that out, you get 22 on 7. So that means a person is 22 on 7 meters above the x-axis. To work out how high above the finish line, you need to take off 1, because the finishing line is a meter above the ground. So you have to take off 1, because that gives you the height from the x-axis. If you take off that, it will give you the height from the finishing point. Right, so it's, so 22 on 7 take 1 is 14 on 7, which is 2 meters. So it's actually 2 meters above the finishing line. Okay, next one is, how far does a person travel on the Flying Fox? That's used the distance formula, which is that formula there, and so you can substitute in the points. It's pretty straightforward to get root 58. What is the domain and range? You can see that the domain is the range is the x values that it takes on, and it goes from -2 to 5, and the range is 1 to 4. You can see that back here in the graph. You can see the domain goes from -2 to 5, the range goes from 1 to 4. You can see my other videos if you need more explanation of how to do those. Now to do part G, you've got an automated camera moving down given by that line. So we've got two equations. One equation is the Flying Fox, and that's this line going down here, going down there, that's the flying fox line. That's our y equals 3/7 x plus 13 on 7, and now we've got a new line which turns out to look something like this, and the camera's on that line. It can go up and down there, taking a video of someone going up and down the fox line. We need to find out where they intersect, because then they'll have the same height value. So if we come down and do this algebraically, we'll then actually compare it on the graphics calculator, see if we get it right. Right, so the two equations we write down in general form. So equation 1 is what we've been given in the question. That is the camera equation. This here is the fox equation from the part above, in general format. Now, to use elimination method with this, we want to eliminate one variable. We can eliminate x, so we need to get that to 6x and that to 6x, so that when we take them we lose it. To do that, you times the whole of the top by 3 and times the whole of the bottom by 2, and so you get that equation there and that equation there. When you subtract them, the 6x goes and you'll get y equals 44 and 23. Now to get the corresponding x coordinates, substitute that back into either 1 or 2. I've substituted into equation 1 and put it where the y is and solve for x, and x comes out to be 6 on 46. Okay, so now we know the intersection point 6 on 46 and 44 on 23. So that's approximately, it's about 0.13, 1.9. It's about the approximate intersection point. Now let's actually just see it on the graphics calculator. Now let's just see it on the graphics calculator. You just put the two equations into y equals, so that's already been entered there, 3/7 x 13 on 7. The second one minus 2/3 x plus 2. And we want to do zoom fit, so it's zoom 0 or zoom fit. We'll do the best scaling for us. And so here comes the flying fox equation. It's the 3 on 7 plus 13 on 7. Here comes the camera equation. Can't remember what that is. So, and we need to find the intersection point. To do the intersection point, we go second calc, intersect 5, and it says first curve yes, second curve yes, guess yes, because there could be more than one, and the answer is 0.13, 1.9, so that agrees with what we've got algebraically. The next one is, when is the camera 2 meters above a person on the flying fox? I'll kind of asterisk this because it's just a little bit harder, especially considering the amount of fractions that come in with this one. So the test won't be this hard. The camera will be 2 meters above when the difference between the y value of the camera and the y value of the flying fox is 2 meters. Now we can rearrange to get the y of the camera, and can we rearrange to get y of the fox, and so we subtract those two and they have to be equal to 2. Now if you solve that whole equation, you'll end up with that x value. So at that point it's going to be 2 meters above at that particular x coordinate. Okay, number 4, use technology to graph this reciprocal function. So we can do it theoretically. We know that there's an asymptote at -3, so you do a dotted line at -3, and they've both got to be positive, but you could do that on the graphics calculator and you'll get this come up. Make sure you do the window range so that you get most of the screen showing both of those curves. What are all the asymptotes? Well, there's 2. There's the vertical line, that's x equals -3, and there's the horizontal line, y equals 0. What is the y coordinate of a point on the curve with x coordinate of 5? Well, if you've got an x coordinate of 5, you need to put 5 in where x is. So if you put where x there is, you put 5, that'll be 8 squared, so it's 1 on 64. So the y coordinate is 1 on 64. What is the x-coordinate point with a y-coordinate of 25? That means you put 25 where y is. So if you put 25 where y is, you need to solve for x. You rearrange that and you'll end up with two answers. Because when you square root, when opposite squaring a square root, you've got to put the plus and minus. And if you follow that through, you get those two answers there. In general, the bridge below can be represented by that function. Place an origin in the appropriate location to suit the function, so you can determine the domain. So if it's there'd be an asymptote at A and B, so we could call that A and that B if we place the origin there. So it's A across to the first pylon and it's B across to the second pylon. So the domain will go from 0 all the way over to this point here. Now that point there is B plus A, will go right to that. This is really a reciprocal function that looks like this. This would curve up like this, and you have a dotted line at A, and then it's going down and then goes up, and then you have another dotted line and it comes down like that, heads towards. And so we're restricting it, we're cutting it off there, and we're cutting it off there, and also we're making an assumption here because it shouldn't actually touch, but the pylon has a thickness there, so it could be modelled as a reciprocal function. Okay, and 5, we have a mobile tower. To read the centre, you just read off 3, 2, and your car is at 9, 5. So the distance, use the distance formula, is root 45. Now the radius from here is root 40, so since the distance is bigger, it's sitting outside the circle. Will you be able to use your mobile phone? No, because you'll be outside it. And you've got to provide 3 points that lie on the boundary of the mobile reception. So one way of doing that is you look up here and do the point which would be easy would be if x is 3, that'll make that 0, and you solve for y. So down here, if you put x is 3, you got that equation, and you then get y equals that. So these are 2 points, 3, 2 plus root 40, 3, 2 minus root 40. If you want a third point, then you can do it when y equals 2, because when y equals 2, that'll make this 0, and then you can solve for x. Just, it's a lot quicker to do than if you chose something, or if you chose y equals 1, it's a lot harder to solve this whole equation here. And so that's 3 plus root 40. So there's 3 points that would lie on the circle circumference. And the last one, they give you the equation of the circle, and you have to find the unknown k, where they give you the radius is 4 light years. So you've got to use completion of the square. You come down to minus k plus 52. That has to equal 4 squared, or you could consider the square root of that being 4. And then when you solve that, you'll get your k value, which you can't really see. You could easily work that one out. So you've got to square both sides, get 16, and then take 52 and divide by minus 1.